Hello, and thank you for joining. Today's topic is additive manufacturing for spare parts. This webinar is being presented as part of a series of webinars that Blueprint is rolling out over the course of the next year, exploring different business aspects of 3D printing. So who am I and why am I here? I'm Aaron Hurd, a manager with Blueprint. Blueprint is an additive manufacturing consultancy and a part of Stratasys. We help our clients understand the business case for and make sense of additive manufacturing. I love getting email from people outside my company, so my email address is on the bottom of this page. If you have a question about anything presented today or would like to get in touch, please email me. If you would like to email my team, we are always happy to say hello. The Blueprint team can be reached at hello@additiveblueprint.com. Before I start in, I want to give you an understanding of who this webinar is for. If you are listening to this, you're probably interested in some aspect of using 3D printing for spare parts. You could be a director of supply chain, a vice president in a spare parts business, or a principal engineer evaluating a technology. Of course, anyone is welcome to attend, but the content of this webinar will be about the high-level business case for 3D printing in spare parts. It is not technical. Now, I am aware that there will be a number of people watching this webinar who already have experience with additive manufacturing, but there will also be some people for whom additive manufacturing is a new concept. Don't worry, I'll be sure to go over the basics before we dive in. Before we get into the meat of this webinar, I'd like to define some terms. If you're here, you've probably heard the terms 3D printing or additive manufacturing. Maybe you have some professional experience using additive manufacturing, or maybe you have a 3D printer at home. In this webinar, I want to be clear what we're talking about. We're talking about industrial equipment like the machines you see pictured in the middle column. These industrial machines are used for applications ranging from prototyping to innovation to end-use parts, and they are used in leading global companies that you will be familiar with. Finally, I want to call out that I will be using the terms additive manufacturing and 3D printing interchangeably in this webinar. So when we talk about 3D printing for spare parts, what problems are we trying to solve? Often problems in a spare parts business show up as dissatisfaction among loyal, long-term customers, missing regulatory requirements, or unexpected, unexplained costs. Ultimately, the two root causes of many of these challenges in spare parts are cost and lead times. Solving cost and lead times increases part availability and solves many of these negative downstream effects. When looking at additive manufacturing for spare parts, we're looking at improving costs and lead times. One thing that we have to be careful about when talking about 3D printing in any application is making sure that we're looking at applications that make sense. What does this mean? It means that we're looking at the intersection between what's technically viable, what's organizationally viable, and what's economically viable. While we will be focusing on the economic side of the equation in this webinar, it's important to keep these other two factors in mind throughout this discussion. So I said previously that a lot of the problems in spare parts come down to cost and lead times. We're going to take a look at both of these things. We'll start with part cost. When does 3D printing make economic sense? Ultimately, it comes down to these two factors. You have a high likelihood of incurring or recurring fixed costs in your supply chain, tooling, or manufacturing setup, and you predict that you will be producing at low volumes. Now that sounds simple enough, but behind this assertion is a certain amount of complexity which we will unpack over the next few minutes. We know that manufacturing has economies of scale, but why is this? Ultimately, this boils down to the fact that at volume, we can amortize fixed costs of production over a large number of parts. Every time you want to produce something, you incur some costs that are fixed, no matter whether you are producing one part or 1 million parts. This includes your supply chain costs, such as sourcing, purchasing, and logistics, your tooling costs, including design and tool production, and your setup costs, the cost to set up your production line or to start up each production batch. So if you incur this overhead and produce just one part, the total cost of that part will be your marginal cost of production plus all of your fixed costs. But as you produce parts in greater and greater volumes, these fixed costs can be amortized over greater and greater numbers of parts, and your total cost for each part will approach your marginal cost of production. We've talked about production economics. Now let's briefly talk about inventory. In any production business, you are going to have some level of inventory, and usually, in a spare parts business, you are going to be storing inventory for parts that are not in active production. Now we know that inventory has some costs. Carrying cost, the cost of money that we have tied up in inventory; shrinkage, the inventory we must write off when it becomes lost or is stolen; and obsolescence, the cost of inventory that we hold until it is no longer useful. But how much inventory should we store? In a spare parts business, this decision can have massive financial impact and is a decision that no business gets right 100% of the time. You can stock more inventory to increase availability, but this certainty comes with certain costs. Regardless of how much inventory you stock, at some point for some parts you will have to reorder, retool, or resource, which means that you will reincur some of the fixed costs of production. But now you're not producing at full production volumes, and you're amortizing your fixed costs over a smaller number of parts, so your total cost per part is going to increase. This is where additive manufacturing can come to the rescue. If you think of 3D printing as an alternative production method and compare it to traditional manufacturing methods, such as injection molding or vacuum forming, you'll notice something interesting. You'll notice that 3D printing generally has much, much lower fixed costs of production. You'll also notice that 3D printing sometimes has higher material costs. When you start to run the numbers, often 3D printing can become a lower cost production mechanism when you get into lower volumes. So, if you take away one thing from the last few minutes, it's that 3D printing is an alternative manufacturing method with lower fixed costs of production than many traditional manufacturing methods. And it's these lower fixed costs that can give it an economic advantage at lower volume production. I mentioned earlier that lead times was one of the root causes of many problems in spare parts. So let's briefly explore what 3D printing can do to lead times. The table on the screen shows examples of typical lead times given traditional manufacturing processes for a few different parts. Often traditional manufacturing processes require some combination of tool design, tool creation, and line setup prior to production, and lead times are often measured in months because of this. Now, I'm not going to dive deeply into what is required for each of these different processes, but it varies widely based on geography, design, or, frankly, how much you are willing to pay. Just like there are different traditional manufacturing processes, there are several different additive manufacturing processes, each with their own lead times and post-processing requirements. But, as you'll see from the table in front of you, the lead times to first articles are generally significantly shorter than traditional manufacturing methods. So, in theory, additive manufacturing can reduce lead times and total costs of parts that are manufactured in low volumes. But what does this look like in practice? I want to show you two examples from projects that my group has worked on to show you where this can make sense in the real world. The first case study is a small nylon gear that an office equipment refurbisher needed to repair $10,000 office copiers. The original part is injection molded nylon and is produced in volumes on the order of 100,000 parts. This particular part went end of life several years ago, and now our client is out of stock. Unfortunately, to produce a new mold and tool up for even a small run of this part, our client's supplier requires several $1,000s and 6 months lead time. As a concept demonstration, the Blueprint team redesigned this gear for additive manufacturing and printed a functionally equivalent part. With a few hours of engineering time, we were able to get first articles to this company overnight, and we gave them an option for more economic production at all volumes below 2,500 units. and we cut 6 months off their lead times. Additive has spare parts applications not only in directly producing spare parts, but sometimes in augmenting traditional manufacturing processes. We worked with an auto manufacturer on a part like the one on your screen. In this case, we designed and printed a tool that could be used for vacuum forming parts. Since our customer was only planning on running a few hundred parts off the tool didn't need to be produced of hardened steel, and industrial-grade 3D printed plastic was sufficient. Again, this had significant advantages in lead time, shortening the lead time by as much as 6 months, but the 3D printed tooling also helped reduce our clients' fixed costs of production. Although I gave you 2 specific examples, there are a number of leading companies who have published examples of where they are using additive manufacturing for spare parts. Siemens Mobility was able to transfer 90% of their slow-moving part inventory to 3D printing in a rail maintenance facility. Porsche has launched a program to use 3D printing to provide any part for any Porsche car ever made, with huge implications for long-term customer loyalty. And Whirlpool has performed an analysis of their product catalog and found that almost 1,000 of their 11,000 SKUs were both technically and economically viable to 3D print for spare parts. Now that we've seen how 3D printing can be economically viable and provide drastically shorter lead times in a spare parts business, I want to briefly touch on what rolling out an additive capability in a spare parts business looks like. In organizations that Blueprint has worked with, the journey to deploying 3D printing in a spare parts business has generally followed the same path. First, you want to solve immediate problems by opportunistically identifying out-of-stock parts that are candidates for 3D printing. This will enable your engineering teams to learn what's possible, as well as what amount and type of engineering effort is required. Next, you'll want to build an internal capacity for 3D printing and start to integrate evaluation of 3D printing into your supply chain process. This will enable you to start engineering activities once spare parts inventory reaches minimum acceptable thresholds. Finally, once you've integrated additive into your spare parts supply chain process, you'll want to optimize. You'll optimize your engineering process by designing for dual manufacturing. You want to optimize your supply chain process by evaluating the costs of additive during initial part design so that you know when to flip the switch. While one slide cannot address all of the things that you should consider when figuring out if and how to roll out additive manufacturing capability in your spare parts business, hopefully this gives you an idea of what a capability development looks like at a high level. Getting more tactical, what action steps do you need to take to get started with identifying opportunities to use 3D printing at your organization in your spare parts business? The first step is to identify your program champions and set goals. It is important to identify an owner for this initiative who can make this a priority. For your first steps into using 3D printing for spare parts, your goal should be to find a few cases where you can show that 3D printing is a great solution. If you have an engineering background, you might be tempted to convert as many parts to 3D printing as you can as quickly as possible. But remember, the goal here is demonstrating 3D printing toward the end of organizational acceptance. Second, you should rapidly upskill both your champions and the staff who will be implementing this initiative. These people will be driving the identification of candidate parts for 3D printing, so they need broad knowledge of what the different technologies are capable of. Next, identify key departments within your organization and run a 3D printing 101 workshop for those departments. Remember, not everyone knows as much about 3D printing as you do, even if watching this webinar is your first foray into 3D printing. And participants within these key departments will need at least an awareness level to help your champions identify candidate 3D printable parts. Work with those department participants to generate ideas for candidate 3D printable parts. You can do this through workshops, iteratively ideating, or a series of factory walkthroughs. At Blueprint, we have a concept canvas tool that we've developed to help guide this conversation. Finally, perform the technical and economic analysis of these parts. This will almost certainly require the expertise of someone who has used 3D printing extensively. If you have a 3D printing capability within your organization for prototyping, this may be a good time to engage that department to help understand technical feasibility and cost. The above should give you a good idea of how you can get started, and it may seem daunting, but that's why we at Blueprint are here to help. In closing, I want to bring us back to why we were here in the first place. Most pain points within a spare parts supply chain are solved by reducing fixed costs and lowering lead times. 3D printing trades higher material cost for very low fixed costs of production and shortened lead times. We saw several case studies of both specific part-level applications and heard stories of how leading companies are using 3D printing within their spare parts businesses. And finally, we framed what the pathway to developing and deploying an additive manufacturing capability would look like within your spare parts business. With all that said, thank you for watching this webinar today. Again, I'm Aaron Hurd with Blueprint. If you have any questions about the content in the webinar, I encourage you to email me at the address you see on your screen. I'm happy to clarify anything in this presentation or have a discussion about how additive might make sense for your spare parts business. Thank you again, and have a great day.